let me take a quick second and just tell you who our company is. We represent a product out of Italy. We're basically an OEM. We represent it for all of North America, and it's the 3NTR FDM printers out of Valiggio, Italy. And a couple of firsts for us in our industry is about 4 years ago, we developed a material management system for handling of materials, which we hadn't seen out there in the market anywhere, integrated into our systems. And then realizing, especially being from the Northwest, we know that the environment is critical. So we built in filtration and humidity control for all of our printers. So that's all integrated in there as well for clean and healthy printing. And we care about the entire process, which is the printer, the materials, and all of the processes to get your finished part. Probably more than anything else at our company, even though we represent printers, we have a strong material science program going at our company where materials are really the primary reason for people developing applications. The printers are just the vessel. So we have relationships with global material companies, and we've actually developed some very cool visual tools because we got tired of people asking us, how does this material compare to another material? So now you can look at it visually for some of the top 5 or 6 properties of the materials. Spectral 30 itself is kind of a breed apart. It's a product that we haven't seen anything like it in the market right now. And it was a combination of a development project between Airbus, our manufacturer, 3NTR, the Clean Sky Project, which is an institution in Europe that is focused on lightweighting products and focused on environmental aspects of manufacturing. And then the Horizon 2020, they run the largest research and innovation project ever since the EU was started. And then Rescol is a global materials company. This is the Spectral itself. It's a fully integrated system. Everything built into it. What you see is the entire printer. If you were to rotate it 360 degrees, you'd see basically just flat panels all the way around, other than a power cord going out the back side. Let me run into some of the major specifications of the printer. It's got 4 retractable nozzles that run at 500 C, and the opportunity here, and I'll show you in a later slide, is literally to be able to run not only backup materials or backup extruders, but also the ability to have run PEEK and ULTEM, or PEC and ULTEM, 2 different jobs at the same time in the same build with running 4 nozzles and 4 materials. We'll talk about those materials. The system comes with, and this is another unique aspect, 4 smart independent dryers. They automatically will take this very expensive material up to its drying temperature once it's loaded, and then we'll drop it down to its dew point and keep it dry, so you can be assured that moisture is not an issue when printing with these very expensive materials. We have a very unique print bed that is made out of solid carbon fiber and PEI. It slides in and out on on magnets, so it's automatically level. Print bed will last for thousands and thousands of parts. There's absolutely no glues or films or anything that you need with it. And again, it'll run to 300 C. The printer is really future-proofed in that there are only 1 or 2 materials out there in the market that can actually work in environments that are hot. And the build chamber itself is 250 C. So that opens the door for new materials from Arkema, like their PEC semicrystalline, which can handle some very, very challenging environments, like 2-3 miles down under the ocean, handle the pressure, let's say, in an oil and gas environment. Some of the additional specs I'll run through very quickly. Generally, I have a slide for each of these. The liquid cooling gives you even flow, keeps your nozzles at an exact temperature, as flowing plastic is very finicky. 10-inch touch screen, fully automated nozzle build plate leveling. Again, back to the need for fume extraction for both VOC and, sorry, the other escapes me.
Particulates.
Well, yes, but I can't think of what the other one. And we have an integrated vacuum system for material R&D. So there's a switch on the back. You don't, generally speaking, you would need to run a vacuum system at all. But if you wanted to try materials that might require additional holding power, you could actually use a vacuum system. But I don't know that it's necessary for many parts. Another huge thing is the 30-minute warm-up time, as opposed to hours and hours from some other leading vendors to get to ready to print high temp materials. Complete job reporting, kind of an industry 4.0 model. Basically, it will track all of the parameters, what's going on, how hot the part was at a particular point in time. All the parameters related to the build will, you'll be able to push that out into whatever format you want. And then literally when that door is closed, you almost cannot feel the heat and almost no sound coming out of the printer. I'm showing you this material slide because at the very top are the ultra high performance materials, but it'll also print anything. The reason why someone would acquire a printer like that is not for anything below specialty, but should that ever be required, that ability is there. So we're printing with PEEK, PEC, Ultem. We're working on a wide range of interesting support materials. We're working on a soluble support for Ultem 9085, which doesn't exist in the world right now. We don't know if we'll get there, but we're testing with a third-party material, which is pretty exciting. Give you an idea of some special parts. Every engineer has their shiny unicorn drawer, but give you an idea of some of the PEEK parts we've printed out of the printer. Natural and black Ultem we're printing. This is a 12-inch PEEK using PEC A. That's basically a converter. And here's a PEEK part at 5-inch diameter, a coolant impeller. And then this was a bracket that we printed for a company that flies about 80 to 100-pound drones to replace metal parts. And we've also found a 35% filled nylon that works well too to replace the metal brackets. I moved through this fairly quickly, which I think was the plan. You can join us on our virtual booth and talk with Matt. You can watch a video, our first effort at videoing with social distancing on the printer, and then we have a teaser video there as well. And if you want to learn anything more about this particular printer, we have the first one in North America in our offices, and actually the only one in the world that's assembled right now, because at the factory in Eligio, Italy, there's 12 of them that are 80% built, but then COVID hit. So we have the only running Spectral in the world right now, which is kind of exciting. Or you can reach out to me at any time you like to talk more about the Spectral. And Sarah, at this point, I'm done with the presentation. Moved through it fairly quickly. I hope people were able to grasp from the speed, and I'm happy to answer any questions if there are any.
Thanks, Ed.
Thank you, Ed and Doug. All right. Looks like we've got one question from Ivan Curzon. Very nice presentation. What are the principal challenges to print Ultem?
We could put Ultem, PEEK, and PEC in that question as well. And I think the right answer there is when you move to these very expensive polymers, they're incredibly difficult to print because of the temperature requirements. And the other thing I forgot to mention, which will make Ultem print even better on our system, is we do annealing inside the chamber, not only while it's printing, but also after printing as well. So
yeah, I wanted to add real quickly, the annealing process is one of the big challenges. A lot of people can print the polymers, but actually getting them to high performance requires the specific annealing process, which we've built in. And hopefully we've reduced that challenge.
Thank you, guys.
Hopefully that answers the question a little bit. It's temperature driven, and it's constant temperature requirement as well.
All right, and please keep submitting your questions. We do have a few more minutes. From Anonymous, we've got a question about slicers. I'm not sure if you can answer this question, but is 3NTR still using KISS Slicer? What about Spectral?
The
So
Spectral
Go
uses
ahead, Doug.
KISS Slicer at present, and they have it embedded in their software solution called Smart Slicer Interface. So the Spectral will ship using that solution. It is a G-code printer, and other slicers could be potentially used. However, we are going to release with that slicer.
Let me add one more thing to that is SSI, which is the Smart Slicer Interface, is a very simple slicer to use. You can literally learn how to use the printer pretty much within about an hour. SSI is that simple. KISS Slicer is there as well, which again gives you the ability to dive deeper, tune materials for specific applications, and just gives you a lot more opportunity. But SSI resides on the KISS Slicer application.
The other thing is we look forward to working with Dendrite as the G-code capability comes online. We're looking forward to applying that to our printers.
We see that as a bright future with the Spectral and our other printers as well.
We do too. All right. How are you predicting deformation during annealing? From Michael.
You know,
I don't think we're doing that at this present time.
Yeah, I would have to, actually, that's a really good question. I need to go back to the manufacturer. We've had the printer for a week, so we haven't gotten through all of the functions of it yet in testing, but that's actually, if you want to reach out to me, I'll know who to go back to, and I'll get you an answer on that as well. Be happy to.
All right, and everyone, for reaching out, go ahead and go to their vendor lounge at the end of the day. You can make sure to keep talking with them. We've got one more question. Why, from Anonymous, the question's, I'm not sure how it's phrased, but why everyone look at Ultem or PEEK when PEKK have better performance?
That's actually a fairly easy answer. I agree with that person. And the challenge right now is, you know, the world has accepted Ultem and PEEK. It's going to take time for more PEK to get out there. PEK is incredibly expensive over Ultem and PEEK. And the more of it that gets out there and things start getting certified, the prices will come down. But if you want to see our comparison chart at some point, you can reach out to me and I can show you how Ultem and PEEK compare to PEK, both PEK A and PEK SC, because they are different materials. But primarily right now it's price and just fairly new in the 3D printing world.